A question from Ellen, who wonders what happens if you try to hit a baseball traveling at 90% the speed of light. Let's set aside the question of how we manage to accelerate the ball to such speed and assume it's an ordinary throw. But at the moment the pitcher releases the ball, it magically speeds up to 9/10 the speed of light. From this moment, everything happens according to the laws of physics, and these events unfold very quickly, promising nothing good for either the batter or the pitcher. Here is my best analysis of this scenario. The ball moves so fast that all surrounding objects seem almost motionless, even the air molecules stay in place. While air molecules vibrate at hundreds of miles per hour, the ball streaks through them at 600 million miles per hour. This means that for the ball, the air molecules have simply frozen. The laws of aerodynamics do not apply here. Usually, air flows around moving objects, but the air molecules in front of the ball do not have time to shift aside. The ball collides with them so forcefully that the atomic nuclei of air molecules merge with the ball's nuclei. Each collision releases a burst of gamma rays and scattered subatomic particles. These gamma rays and debris create a bubble emanating from the pitcher's mound, tearing apart air molecules and transforming the stadium air into an expanding bubble of glowing plasma. The surface of this bubble moves towards the batter almost at the speed of light, just slightly ahead of the ball. The constant merging at the front of the ball slows it down, as if it were a rocket flying backward powered by thermonuclear engines. Unfortunately, the ball moves so fast that even the immense force of this thermonuclear reaction barely slows it down. However, this causes the surface of the ball to begin to disintegrate, scattering small particles in all directions. These fragments move so fast that upon colliding with air molecules, they initiate 2 or 3 new fusion processes. After about 60 nanoseconds, the X-ray shell reaches the home base, and a few nanoseconds later, the ball collides with the batter. The batter doesn't even have time to see the pitcher release the ball, as the information reaches him almost simultaneously with the shockwave. Collisions with the air have almost completely destroyed the ball, and now it resembles a plasma cloud, like a bullet, primarily made of carbon, oxygen, hydrogen, and nitrogen, piercing through the air and causing new fusion reactions. When the cloud reaches the batter, its center is still moving at a noticeable fraction of the speed of light. First, it collides with the bat, but then the batter, home plate, and catcher are lifted and swept back through the protective barrier. As they are destroyed, a shell of X-rays and heated plasma expands, engulfing the protective barrier, both teams, the stands, and the surrounding area in mere microseconds. Imagine watching this from a hill on the outskirts of the city. What you see is a blinding flash of light overshadowing the sun, gradually fading over several seconds while a rising fireball forms a mushroom cloud. Then, with a powerful roar, the shockwave comes, uprooting trees and destroying houses. Everything within about a mile of the park is destroyed, and a fiery storm engulfs the surrounding city. The baseball field is now a significant crater located a few hundred feet behind the former location of the protective barrier. A careful study of official rule number 5.05 letter B2 indicates that in such a situation, the batter will be considered hit by the ball and can advance to first base.